I'm just working on an M15R4 that was sent in to me in pieces. It was sent in bags. What's up there, Rusty? So this is actually my first live stream I've ever done. Never done one before. And I won't be able to do it for very long. I have to run in a minute, but I figured I can mess with this laptop that came in pieces. Good morning, good morning. So what I'm trying to figure out here, this one was sent in because the customer said dead battery, not turning on, and they used to use it without the battery, and then they said it just shut off and died, and then they used a thermal camera and a board view and a multimeter, and they had no idea why it's not turning on, so we have to kind of put it together to figure it out first. Hey. So I'm going to try to pull this out just a little bit so I can look and see. We're going to do a quick physical inspection, and then we can try to reassemble and test and see what it's doing. You're holding the torch, huh? All right. All right, can everyone hear me good and see? I'm just going to look around real quick. So this is the DC in. This is where the DC jack plugs in. These are the power MOSFETs that the voltage comes through when it comes in. Let's actually plug it in and see what it does. I have a DC jack here. And we'll look at the power meter. All right, it's pulling 0.02. That's actually good. That means the EC chip's coming on. So what ends up happening a lot of times on these machines is, here's the EC chip. And so we have this LDO chip. This is a linear voltage regulator, has 19 volts on one side and at 3.3. And then that actually powers up this chip, and it's like a microcontroller with GPIO pins. And that's like running a loop of code, and it's checking to see if a power button is pressed. And so here's a power button right here. We can actually press this. And so let's see if it turns on when we press it. And it's doing nothing. All right, so if this is doing nothing, then we pretty much, it could be this chip itself. It could be physically bad, or it could just be a corruption in it. But we need to figure out if there's a short somewhere. Ooh, what's that? I know the guy's been measuring right there. Let's see. This is just an inductor, but it is pretty scraped up. I'm trying to read your comments at the same time. It's kind of hard to multitask. Like I said, this is my first live stream I've ever done. Never done one before, so you guys have to bear with me. I usually just film it. All right, let me measure some of the power rails on this real quick. You want me to put some music in the background, huh? Smooth jazz. I actually get complaints. Oh, the heatsink wasn't even attached. Look, it just fell off. Whew. All right, we got a lot of thermal pads on here. Do we want to look at them closely? I think this might be a little overkill for thermal pads. Is this like double stacked? I don't know, they might be too thick. I mean, it is making contact, but sometimes when you start stacking these things up, you start making it where you're not getting enough contact on the GPU itself. Thanks for the sub. Yeah, you can see these are all the MOSFETs that actually power this, but no, these are the coils actually, the inductors are right here, but this is supposed to be touching the MOSFETs, and there's no pad there at all. Okay, but I guess it's still on here. That's why. No, that's for the RAM. All right, what I want to check actually is we're just going to check a couple power rails, and we want to see if we are getting any voltage on there. Since we are getting the LDO voltage, we know that there's not like a dead short on there because the power management chip, which controls all the power MOSFETs on the input jack, it would shut those off. So we know that we don't have a dead short somewhere, but we still want to check to see if we're getting any voltage here. This is the 3 volt and the 5 volt power rails. Is this meter working? And we got 0 on there, but we have to plug it in, obviously. All right, so we have our 5.2 or 5 volts, and then it shut off. And this is normal. So when we first plug in one of these boards, they're going to power up for a second, and then it's going to shut off. It's basically just testing the power rails. And so now I'm going to check the 3.3. I'm going to unplug and plug it back in. 3.3 came up. All right, let's see if this 1.8 is here. Oh, nothing came up on that one. What about this one? We're not getting any of these other ones. It doesn't mean we have a short on those. It's just whether they're turning on or not. There's the main power rail, and this should be the battery charge inductor here. You know, this kind of seems like an EC issue. It's hard to know. The thing is that the power button, whenever it's not replying, it's not power rails fail on MOSFET. No, because if you have a MOSFET that's failed on one of the power rails, see, everyone kind of goes to the MOSFETs. So on a GPU and CPU, you have these power MOSFETs here, right here. And this one has a bunch of them for the GPU. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And then if one of those was shorted to the main power rail, it would shut off and you wouldn't even be able to power it on. If you had a bad MOSFET on the input jack over here, you wouldn't be getting your LDO. See, because this is all blocking that. And if we had a bad MOSFET on our 3 volt and 5 volt, then we wouldn't have that come on temporarily. So most people would go to BIOS. That's right. I would go to BIOS too, except on this machine, the BIOS isn't loaded yet because the EC handles everything first. So some of the other machines, like an XPS or something like that, I don't work on any other machines. I only work on Dell and Alienware, but XPS Latitudes, those have an EC chip and a BIOS chip, and when you plug in, like if you do a CMOS reset, you unplug all the power, and you plug in the power, the board will automatically turn on, and then it will load the EC firmware from the BIOS. And so if you get a corrupted BIOS, it won't load. But on this machine, the machine will stay off, and the BIOS chip has no voltage. So here's the EC chip. We have voltage at the EC chip. I think, did we measure that? I don't think we did, actually. I'm saying we do. I'm saying we do because we see that 0.02 on the voltmeter. But so here's the LDO. So we got 19 on this side, all right? So we have a bad ground. Okay, 19. And then this side we should have 3.2. So there's our 3.2. And then our EC chip, we can just measure on our power button. We have 3 volts on the power button. Now if we press the power button, we want it to come on, but it's not coming on. So what I was saying is that you would go to the BIOS next, right? Because you would say, oh, it's a bad BIOS. But here's the BIOS chip right here. And if you notice, the BIOS chip is not on. Pin 8 is the BIOS chip voltage. And so it's not even on. So how could it be the BIOS? Right? Unless the BIOS chip is shorted out or something, which I've never seen that before. So on this machine, I've done it a lot. I've seen it a lot, that the EC chip gets corrupted. And it could just be the chip itself that's bad, which usually it's just a corruption of the EC chip. And so that would actually be my next thing to actually try on this. But it is a pain. It's a pain. Yeah, Microsoft loves the brick computers, I can tell you that. The EC chip could have been bricked from a update or not. Do we get to watch? Yes, you can watch an EC. Yeah, you want me to program this real quick? I don't have much time. I actually have to run in about 20 minutes, but we can get this done. quickly. I only fixed, oh, do I fix ruggeds? Reluctantly, yes. I hate ruggeds, but we fix all Dell and Alienware, so, and ATGs, but ATGs are older, but we do have a lot of those parts too still. All right, y'all want to do EC chip? Y'all ready? All right, EC programmer right here. So, yes, it's complicated, but it's not that bad. Okay, so this is a, you'll always ask for the number, so I'll show you. There's the model number. You just search for that if you want to buy it. Or maybe this number. Everyone got it? All right, so this programmer allows you to program ECs through the keyboard controller, but on this board, you can't do that because that would be too convenient. So normally you would just unplug the keyboard, you would plug a ribbon cable here and plug it into it. So we're going to do it the hard way. And luckily, I have these PC Bytes. Have you guys seen these before? They are awesome. It's about $100 for a set of these. I think I have a link in my videos. I usually link to these, but I don't think I have it in this live stream. But anyway, so what they are, they're weighted. And so then they're flexible. So they're weighted, and then they have a needle point on the end, and you can just set it wherever you want it. So that's what we have to do on this board. And then I have these little brackets that hold it. So slide that in there. An Alienware M16R2. The Alienware M16R2s, even the X series, all of those, actually, I think they're pretty good at this point. So Dell is starting to kind of get the memo that the more power stages you have for the GPU and CPU, the better. And so whenever when everyone's like, Alienware suck because they're always having bad GPUs and bad CPUs. Look, it's because they didn't have enough power stages. So you basically have a power MOSFET that powers the CPU and GPU. And if you have like 4 of them or 6 of them, that's not enough. And so these M16s and the X15s, they have like 14 or something like that. So then each one of them can kind of share the burden. And so I'm not seeing any MOSFETs burning up, shorting out, which will cause the CPU and GPUs to burn up. So I'm not seeing that as an issue. Sorry, I'm trying to untangle these wires. Give me a second here. And then I will explain. All right. Almost got it. Yeah, I'm going to basically program this like a spider. Like that. Okay, one last one, sorry. Okay, here's the hard part. Oh, well, I was going to explain it. Okay, so the way I have this set up is you can manually, because I cannot program through the keyboard controller in this, there's programming little pads. They're so tiny. I've tried soldering to them in the past, and it's just ridiculous. So I'm going to use the Shark Byte, or PC Bytes, to actually set them on there. And then I have it set up on the solder headers on this. So you can actually solder this to the board and program it. So that's why I just have the wires on here. And we just need to hook up a couple grounds, and then we will hook up all of the other ones. And whether this will work, I don't know, but this is where we have to go next because this is what logically makes sense. It may just be a bad chip too. I have a couple grounds. The more grounds, the better on this. Okay, now we'll switch to this view. White LED, solid, 20 seconds, and then turns off. I mean, it's powering on. Let's see, XPS 9500. You're gonna make me think of some other issue while I'm working on this. I'm trying to program an EC chip. Let me think about that. I'll tell you. 20 seconds turns off. I don't know. Reset your memory. Unplug stuff. I can't think about that stuff right now. You're making me think of too many things. All right. Get this in focus. All right. So our programming points are tiny, like I said. Everyone can see it. Okay. So we have one here, this little dot. We have one here, we have one here, and then we have one, I think it's this one. Okay? So there's 4 of them. You like how tiny they are? Here's my finger. That little dot, that one, and that one, and that one. And I got my cheat notes here, because I program these a bunch, and so I always make notes whenever I figure out how to do something. Well, thank you. Thanks for buying stuff from me. All right. Okay, so the first one we're doing is, let me do the green one. The green one's going to go up here at the top. Right there, and see, these are great. See, they're like little needle points. Let's see if I can get this better in the view. Okay, they're like little needle points, and then they're weighted, so they set right on there. There you go. And the next one is going to be KSI 6. 6 is going to be yellow. Do yellow on this side. And then we're doing blue. Let's see. And it's so tiny that everything kind of runs into each other whenever I'm trying to do it, so it becomes kind of a pain. All right. Can everyone see this? Here, I'll add the second camera because sometimes it's hard to see this. Okay, let's put this camera right here. Is that better? You guys like that too? Booyah. All right, and then purple's our last one, I believe. KSI 7, no wait, KSI 7 is blue. See, I'm distracted. Purple is 4. I need to switch these two. I have to say, this is kind of hard to live stream and do a repair. You have to kind of think about multiple things. All right. We're in there. Don't move. Don't breathe. Okay, let's do, I'm trying to think of what view to put us on to be able to see better. Can we see that? Let me think about this. All right, let me get the program software pulled up, and then I will switch to that view for you. You guys are funny. Okay. We got the crazy screen a little bit. But can you see the programmer? That's the question. Let's see if we can try this out. All right, so I'm going to plug in the programmer first, and then I'm going to check. Well, I need to choose it's an E&E chip, and I need to check I'm connected. Okay. There we go. Come on, it's not working. There we go. Okay, so once we do this, so on this machine, you choose E&E, and then it allows you to choose a motherboard. And when you're choosing a motherboard, this is all going to be based on using the pins on the ribbon cable. So you would just, if you had an LA 7981P, you would select that. I don't know why I threw an error just now. Here, maybe if I choose this one. And then you would choose how many pins the cable is, and then what orientation the cable is. But we're not doing that. We're actually going to be using the solder points. And so I actually need to look for one that uses a certain chip. And so these boards right here are going to be using the KB9542GF EC chip. And then I'm going to set up the soldering. And this will tell you what the pinout is. And I've already have it set up because I do that all the time. And I got to send that to the programmer. All right, so now if I test connection, I get an error. But I need to power on the motherboard itself. So we're going to plug in the power for the motherboard. And then we're going to check connection. And of course it didn't work. So now we got to double check connections. Here, sometimes I can just unplug it and plug it back in. Nope. So we get the double check connections. Let me go back to the microscope real quick. Ah, can you see it? One of them fell off. Yes, you're right. This green one is not on its pin anymore. It goes right, get in your home. All right. So now, switch views. Okay. I got to replug this in. Let me double check my colors again. So purple and yellow. Green came off, yeah. Purple and yellow, 6 and 4. And then blue's down there. Yep, okay, green is 5. Okay, so those are all right. So I have them in the right place. Let me just reseat them all. That's kind of how I have to do it. This blue. Okay. Check it again. You're gonna make me mad. Okay. All right, I don't know what's going on. Sometimes it does this and I have to kind of mess around with it. I'm sure you guys enjoy that beeping sound. Yes, 200. Oh wow, 244 people. I didn't realize that. I thought I was talking to like 12 people. Well, awesome. Thanks, guys. Appreciate you coming aboard. Well, you might be seeing an epic fail, so that's perfect. All right, I'm just going to start this over, reconnect, reselect all this stuff. So for those who just joined us, I'm working on a M15R4. It was sent in to me in pieces, and it looks like it has a bad EC chip, and so I'm trying to program it. And this is my first live stream. Never done it before, so hopefully I'm doing well, but I find that it is kind of hard to multitask. All right, I'm gonna redo all these again. This is irritating me. Okay, we just reseat these. Sometimes you have to really get them set in there tight. right. Don't, yeah, I feel a lot of pressure. I'm glad that you don't feel pressure. I feel pressure to perform. Hey, come on. Come on. Why is this not working? Oh, gosh. This is ridiculous. And maybe the EC chip's just bad. I mean, that would actually make sense. And then you guys get to see me put a new EC chip on, too. Oh, thanks. I appreciate... wow. Okay. This is ridiculous. It's making me mad now. Not mad. I just get frustrated sometimes. All right, let me reseat this one. You know, I'm wondering if I'm putting this one pad on the wrong one. I might be. I can never remember on this one. Because see, what's crazy is I like to go by memory, and I don't know why I do that. It might be this one, and I'm putting it on this one. All right, let's try that. My old age. Didn't work either. Clean motherboard with alcohol, yes. Oh, proper calibrated wires. That's where I'm missing. I need a proper calibrated wire. Oh, Soren. Soren. Easy pizza. I'm glad all you guys support him too. I definitely watched pretty much every single one of his videos. I definitely enjoy it. I don't think he's too slow, like some people think. Oh my gosh. You know, it's funny because I've had this happen before where I'm just like, just keep moving these around and finally I get it to connect. But I don't know what it is that's causing it to not work. And I'm almost running out of time. Like I said, I have to do a short one of these. I'm going to reopen the program. You guys probably can't even see the program because I'm not on that view, but okay. Test connection. I'm about to have to pull out a board view real quick. All right, breaking the rules. I generally don't like to do board views, but we are going to do one. All right, you see my board view? All right, so here's what we're looking at. What are we looking? What are we looking at? We're looking for the EC chip. It's over here. Here's the EC chip. And here's that pin header, pin, but the one that I'm missing is where it is. This last one right here, and we got to look it up in this list. It's going to be there it is. There it is. It's that one. Huh. Okay, so it's set up a little differently than I was remembering. Okay, so we're going to keep in mind it's going to be these three resistors, and it's going to be on that edge. We might be able to do it on that side, but we're going to do it on that side. The enable is the other one that I was looking at, but we don't need the enable on this board. So back to the microscope. Here, let's see if we can do this view. That view is better. Does that view a little bit better? Okay. So So here's that resistor, and the resistor, and I was putting it on this side, but it needs to be on this side, which I did. It is tied to this. That's what I had it hooked to. So my memory isn't wrong. So like I said, it's that resistor, resistor, resistor. They're not populated. I mean, that's why they're not there. But and then you can see that this has a trace that comes over to this, and that's what we're doing. So maybe, I wonder if it's just not touching good enough on some of these. I'm going to put it right on top of that one. Put it right on top of this one. Get in your home. And then right on top of this one. Get in your home. And this one needs to go home too. Gosh, they're so tiny. Okay, is it gonna work? Crazy screen. All right. Hey! Connected. Okay. That took a while, but we worked through it together. We did it. Okay, finally. Okay, so we're going to read this real quick. And let's, I'm going to back it up real quick. Let me get the customer's number real quick. Let's see. 25317 is the repair ticket number. And we are going to back it up as just the original. Boom. And so all I'm doing is just backing up the contents. So the idea is, like, you know, if I need to put it back, what's stored in here is going to be their service tag and the board part number, serial number. We can actually look at that, and I can show you that. If I can pull it up. Come on, where's it at? Here, let me go find it. Throwing some hearts at me, huh? Where did I just back up this file to? I swear I put it in a folder here. Backups. Here, let me do it again. Just figure out where it's opening to. Oh, I put it in downloads on accident. So the way I organize my stuff is I have a backup of every single machine I work on. And so those are all the BIOSes I've worked on. Look at how many there is. Oh my gosh. I didn't realize that. How many? 128 BIOS repairs that I've had to do. Sometimes I have 2 or 3 per week, which is just nuts. Thank you, Microsoft. Anyway, and then in here, I download, every time I have to download a BIOS that I'm going to be ripping apart, that's where I get that. So let me move this over to the right folder. All right, so we have the customer's EC chip, and let me close out of all these so you don't have to look at all these other people's stuff. Okay, and we don't need that view anymore. All right, so here we go. Here's our EC contents, and down at the end is going to be where their service tag is and the serial number and all that. So here it is. Boom, boom, boom. Anyway, I backed that up, and then what we're going to do is write back a new one. And do you guys want me to show you how I extract a new one from a Dell BIOS, from Dell's website? Or do you want me to just flash one to it? I will show you. The silence is killing me. Okay. So we're going to come to Dell's website, and we're doing 15R2. No, 15R4. Thank you for correcting me. Downloads. And we wait for it to load. Drivers. BIOS. And we're going to download we're not going to hit the download key because we don't want this version. We don't want the exe version. We actually want the RCV version, which is their BIOS recovery file. And so when we download that, and then I'm going to rename it to have this because it actually isn't named right. So I like having that nomenclature there. And we'll go back to the downloads. And so see how it names it BIOS image, and then I'm just going to edit that, and I will paste in the name. All right, so now I'm going to cut this and take this into my BIOS recovery or my BIOS download folder, and paste it in there, which I might already have one in here. Cut the wrong thing. Cut. Paste. All right, there it is. And then we're going to copy this entire name because we want to. No, because we need it. Sorry, I can't see all chat. Let me move back. Okay, I got your chat pulled back up. What am I doing? Okay, so now we need to use the extraction tools. I usually just right-click in here, open PowerShell, and it's mapped to it. Okay, so there's going to be a few different ones. You can download these on GitHub. And you search for it, Dell PSF, PFS extract. That one works on latitudes and XPSs. But when you download it from GitHub, it's going to be just a bunch of them. And if we just keep going down, there's going to be a PFAT extract. This one, the inside, and then this AMI UCP. Those are the ones that I'm going to be using. So I believe it's going to be this PFAT one. So let's do that one. I just try them until it works, but paste that in there, extract, boom, look at that. All right, so we have it extracted, and we come back in here, we should have a folder. There it is. That's our extracted folder. And inside there, you're going to have all the different parts of the BIOS file. So this part right here is going to be, well, actually, this is the main. So this is the main BIOS. And look at this. Look at this beautiful file right here. We have an EC, 160 kilobytes. Yep. So Acer's, all the different manufacturers are going to have different types of compression for that. So that's why I just say you download that from GitHub, you download the entire pack of extractors, and then you just kind of have to try each one. So anyway, we're just going to copy this EC out of here, and we will put it into our folder, our working folder. Paste. Okay. So now we can go back and write it. Find it. All right, so here's our new one. Wait, this was our new one. Same size, and now it's writing it back. 128 kilobytes are going to be 9542s, like the older style, but the GFs are the BGA, and they're 160. And so that's what's going to mess people up. So when I first got this programmer, I kept having an issue where I couldn't get it to write, and it was like over and over and over and over again, and I realized that because I wasn't selecting a board that was a 9542 GF, it was setting the chip size to 128, and so when I would extract the chip, it would extract at 128 and be all messed up, and then when I tried to write the chip back, it was only writing 128 kilobytes. So these are 160s, and oh, thanks for the bucks, appreciate it, thank you. So I have it written on there. All right, so it's either going to work or it's not. And this was either a waste of time or it was not. So what do you guys think? Because I got to log off in a second and then we can continue this tomorrow if it doesn't work. But I'm going to unplug everything and we're going to move this stuff out of the way. And moment of truth. And so the way we're going to test this We're going to use the power meter. You guys always ask about that. That's my power meter box that I made. How I can actually show you. It's just a 3D printed case that I made. I designed it, and it is these Amazon little screens. And at some point I'm going to do a video on how to build it and have links to it and all that stuff, but the screen just fits in there. And then you're going to use a DC jack from a gaming laptop. It has to have a lot of power. It has to be able to carry a lot of loads. And then you'll use an old power cord. That's what I usually do, is I just cut up an old power cord. And on this particular model, I have it set up where I have both power cords for Dells. You're going to have the 7.4 millimeter and the 4.5. I'm going to test it in a second, you guys. Okay, all right, we'll test it. I will stop talking about that. All right, here we go. Hey, thanks for the $10. All right, let's see. So we're going to plug it in. We're going to keep an eye on the power meter. And we're going to hit the power button. If it doesn't work, yell at me. All right. If it doesn't work, I'll have to deal with this later. We'll continue it later, but because I got to run. But all right, there's our power button we're going to press, and just keep an eye on the current. Aha! 1 amp. Come on, baby, you could do it. 2.6, 2.33, and we got to shut it off before it fries the CPU. Boom. There you go. That was it. So once we just reassemble it, everything will work. Caps lock on. I'm just reading. Oh, that was a good one. Well, hey guys, I appreciate you all joining in on this, my first live stream ever. Hopefully you guys learned something, and it wasn't as bad as I thought, except it's hard to multitask a little bit, so I have to work on that. So, all right, but I appreciate you guys, and I'll see you